Hi again. This lecture is referring to the problem of center of masses, but this time it's referring to negative mass. What does it mean? Suppose you have a plane surface and you do have some holes inside that surface, and you want to find out what is the center of mass of this new shape. Okay, so in order to solve the problem, we can follow the same formulation, which is x is equal to xi mi divided by summation of m, and also the same for y, but with small differences. So we can assume that the center of mass of the plane is located at its center point. So suppose the dimension of the surface is 1 by 1. Suppose it's a square and the dimensions are both equal to each other, 1, and this side is 1 as well. So the center of mass is located at the center of this square, half and half. Okay, and we do have some holes inside that plane. So you can see here on this graph there are 3 holes, and depending on their surface, you can see that they can have different masses. So the mass is proportional to the area of each circle. Okay, so for simplicity, we are assuming that we know the locations of each hole and also the surface of each hole. Then in order to solve that, we can easily apply the same formula. So let's have a look at the Python code. So as I said, the mass of the plane is positive because it exists, and those holes, since they do not exist, we will consider them as negative masses. Okay, so here you can see the Python code. So here, first of all, we import the required packages, and then we define a abstract model, and also there are some parameters needed, the number of circles. Let's assume the default value is 5, and a set I which is ranging from 1 to n. We do need 2 random generator in order to scatter the points on the plane and also their masses. And then x location, y locations are also are the parameters, input parameters, and mass as well. And the variables, we do have 2 variables, model.x, model.y. These variables change between 0 and 1 because the center of mass will be inside that plane. And the rule is the same, but with a small difference. This time the mass of the plane is, let's assume it's proportional to the area of that. Then we can say that it's 1 multiplied by half minus summation of those m's, and actually the area of them is specified here. The m is the radius of those circles, and divided by the summation of those areas. And we can do the same for y. And as I explained, and since this example doesn't have any specific objective function, you can choose any of your decision variables. It's a linear programming approach. You don't have any nonlinearity. If you see a square here, since m is known, there will no nonlinearity be created. And also we have to choose the solver. I chose GLPK, and then I will create the instance, so everything will be fed into the model, and use the matplotlib to draw the graphical shape to show the results for us. So for simplicity, I have chosen 2 points, one for the solved solution, the red one you can see here, and the yellow one is exactly at the center of that square, and those white ones are representing the holes inside that plane. So as far as those random numbers are not overlapping each other, then the solution is correct. Otherwise, this approach doesn't give you a valid solution, okay? Because those white ones should not overlap each other to be able to represent their weight on the solution. I run it again to show you the new results. So every time you run the code, it will give you another set of new solutions. Here you can see that the center of mass doesn't change that much compared to the center of that square. I run it again, hoping I can get a better solution. So this time you can see why this solution is not correct, because there is an overlap between these two white ones. And so this new calculated center of gravity or center of mass is not precise, because those masses are calculated 2 times. I run it again, hoping I can get non-overlapping kind of circles. Okay, so here you actually there is overlap. I run it again. If you manually specify their location, you don't need to run it multiple times. Okay, so here you can see that since all of those white circles are this side of the plane, then the center of mass will move to the opposite direction. Okay, thank you very much.